And with that, let's get started. Hello and welcome to the first episode of Mini C++ Live and the first meeting of our user group in 2023. And tonight, our guest waiting for your questions is Klaus Iglberger. Klaus has a history of being a speaker at various conferences and gave a keynote last year and wrote recently a book. So please introduce yourself, Klaus, that everyone knows what is to know about Klaus Iglberger.
All right. So first of all, a wonderful good evening for all of you who joined this session. And actually, the really first thing I should do is to thank you, Jens, for the invitation. So I'm Klaus. I am, as a daytime, as a job, a C++ trainer / consultant / speaker. So indeed, C++ is pretty much what I do for a living. I usually say I earn my money by speaking about C++, which sounds super boring, but in fact, it's actually quite entertaining, quite interesting. So I indeed recently wrote a book, but I also do C++ very free time. I am the author of a C++ math library called Blaze. And additionally, I'm one of the 4 organizers of the Munich C++ user group, which some of you might know also. All right.
All right. Let's see. There's no questions currently, so let's start with. So I've read your book.
Okay, book. bonus point for advertising the book. Thank you.
Yes. I read your book, and there is a lot of design patterns covered, and I think we're going to talk a lot about design patterns tonight, maybe if people have questions about design patterns. But is there a design pattern that you could not cover but wish you had more, like 100 additional pages? What would be the pattern you would like to write a chapter on?
So truth be told, when I submitted a proposal for the book, actually I had twice as many topics as I've covered in the book. I then later realized that this was just not working out in the agreed page limit. My page limit actually was 350 initially, and we pushed this already because I had just to get rid of too many topics. So there is a lot of things that I would have liked to write about. The thing I regret a little bit was that I could not write about expression templates, which I've used for more than a decade in my own library. There's so much experience that this is something I really would have liked to cover. And it would have fitted perfectly because in the book, I also cover the decorator design pattern, which is exactly what expression templates are. Essentially, they turn out to be a decorator example, static polymorphism decorator, which I believe would have definitely fitted pretty well. Okay, so there was a page limit. I had to get rid of a lot of things. So a lot of things changed quite a bit later. This was the one thing that I definitely wanted to have. I, however, also missed an entire chapter about factories and builders and the like. I could not write about template method, which is truly a shame. This is so easy to use. So a lot of things could not fit, which is, by the way, a good now that I think about it, a good thing to think about a second book, but of course only if the first one actually is a success.
And there was already hinted at a question, and so Jonathan has asked this question. Thank you, Jonathan. Have you ever come up with a clever pattern that you didn't come across before?
That's an interesting question. So I actually have invented a pattern, but much later, I realized that you cannot invent a pattern. This is something that is discovered. This is something many people should have used before you, so that it's a recurring thing. That's part of being a pattern. I have to admit that I did not really invent a pattern as such. I've actually used a lot of things, and later I improved things. And I perhaps realized that it's actually something that other people have used as well, but it's never really was a thing that I believe I could really be proud of. So Jonathan before me told me that he was very proud about having discovered recursion on his own. Unfortunately, did no such thing. And I also have to admit that I initially had not a good feeling about design patterns. I really had no idea at all. It took me quite some time to actually dig in. But this is now hopefully exactly what helps the community. It took me years to really understand them in detail, in a lot of detail. And this is what I now try to cover in the book, and also in talks, in my training classes, etc. Okay, sorry, Jonathan. This is probably the most entertaining answer that you could get. I did not really invent anything, not yet.
So you introduced yourself as a trainer and consultant talking about C++. How much time do you spend to actually gain deep knowledge about the stuff that you then teach to others?
That's a fair question indeed. So first of all, I do a training class pretty much every year nowadays, which means that usually I have 4 to 3 days a week to do training classes. There's not so much time left to actually dig very deep into totally new stuff, but I do keep up to date. So for instance, after breakfast, I usually read a little bit in various books, of course. This is not necessarily C++ books, but also books about software development in general. Then I do the training class, and in the evening, usually I watch a talk, either live on YouTube or whatever. Sometimes on the weekend, I develop new stuff for my training courses based on the inspiration that I got during the week, or also due to the necessity that I need something new. And so indeed, I think a lot of time is spent on this stuff, even the weekends, which sometimes is not particularly great. And so indeed, I do C++ around the clock to some extent. Okay, it sounds worse than it truly is. Yeah, I also do other things. I'm not a C++ addict. So roughly 2 days a week are definitely going into getting to learning about new things, which, however, I feel is absolutely necessary to keep up to date, to not repeat the old stuff that is actually not up to date anymore in the training classes. It's part of being a trainer from my point of view. Which, by the way, does not mean that in the training classes I always talk about the bleeding edge stuff. I don't think this helps people so much. I think my knowledge about what is going to come is more important to them than, is helping them more than truly doing the bleeding edge stuff on their own. My personal opinion, perhaps.
Yeah, I think talking about preparing materials is maybe not as mainstream as the audience would like to have it. But I've seen, like, in 2013, Eric Niebler, and I've heard in the past other people also speak about it, and he's like, yeah, I would love to be a trainer, because back then I think he wasn't, he was like a freelancer or something. I thought he could be a trainer. And he was like, yeah, but keeping the material up to date and like having your versions since then, like all the new standards, keeping that up to date is a lot of work. So
I do not try to keep it at the newest standard, because so this is a reality. The training classes I do are not always for people that can use C++ 20 already. Actually, very few people can use C++ 20 already. This week, for instance, I'm doing a training class for a group that can only use C++ 11. And of course, if I show them C++ 20 training material, then they don't benefit from this so much, because they cannot use this. So I have to keep a compromise. And so some of the material is pretty basic from today's perspective, but it's usually up to exactly the point that these people need.
Okay.
It's just more important.
Yeah, that's, of course, the clients dictate what you teach. That's the other side. Some people don't see so much, which are not trainers or not freelancers. But there is a question from LinkedIn, from Mehmet. Hi, Klaus. Do you believe that with your free function proposal community, did you convince the community? Because, so to some people, C++ gets to the powerful multi-paradigm, and some other people, prefer OP and object annotation. And so what are your thoughts on your free function talk?
So indeed, there was a talk first in 2015. I believe this was one of my first good talks. Before I did a few practice, this was probably one of the first that really was a little better. I know from the reactions of people that some were super happy with this, totally convinced from the start. And I know that some people were exactly the opposite. Some people actually believe this is exactly not what we should do. It's a little hard to convince people from my point of view, from my experience. Either you have an open mind and you have experiences already, or you have a totally different mindset and do not find this appealing at all. I hope in my book I could actually make a couple of additional points. In my book, I have one chapter called Design for Testability, where I pick up this idea again and show that just making a function a free function, it's so much easier to test. I compare this with a private function that still you want to test, and then play through all the possibilities how you could test this private function, and nothing works out well until I finally do this as a free function. Perhaps this convinces a few more people. My point is indeed what Mehmet says. I'm a person that is absolutely convinced that multi-paradigm is the right approach. Every paradigm has its strengths and weaknesses. And so you should know about the strengths and weaknesses, and then of course combine them such that you utilize the strength and avoid the weaknesses, which is not easy, but this is the power that I see in C++. And so pure OO is just too limiting. There's too many problems that you cannot solve with that properly. And the STL is a great example. This could not have been done with an OO approach, not at all. And so this is where Alexander Stepanov was just absolutely correct. On the other hand, there is things that you cannot do in the STL style. I wouldn't want to write a GUI with with just templates and functions. Now, this is where we need an OO approach. So using both strengths is what I feel is great. And so, yeah, I totally agree with Mehmet.
Yeah. I think one important thing to understand is that the talks and the things which are visible to the community over conferences are not always representing like what the reality is where C++ is practiced, right?
Absolutely.
And we have again a question. I'm starting my first job as a C++ software engineer next week. What advice would you give someone switching from academia to industry? Any last-minute preparations you recommend?
So, of course, I have no idea which industry you're switching to, but let's assume, and I think this is a safe assumption, that there is code already. And not just a little bit of code, but there's a lot of code. Yeah, and there's a lot of people that work on that code. And so the biggest thing that is different to industry, and this will hit you immediately, is that you cannot understand everything in this code base together. Now, in the academia codes, they're usually small. Not as I said, usually. There's of course big stuff also like OpenFOAM, etc. But the industry code is bigger. And so suddenly all the things that you've been taught before, things like decouple, or things like you cannot just change things, they suddenly hit your heart. If you try that, you suddenly are in problem. In academia, you're not. It just causes a little bit of a stir, perhaps, but not a big one. I think this is the thing that really distinguishes these two things. So just be prepared for the reality. Things are bigger in industry. There is more people. There's more people with different opinions. And so it's a little harder to actually do the things that you took for granted before. This was my experience initially. I could just not do things my way anymore. I had to do it the way that it was expected. So when I first joined the company, and this also remained true for my second company. You are part of the wheel, part of the big thing. No, you're a small wheel in this big engine, but still an important one as you make this work. All right.
Okay. Let me see. What is the next question?
But it's a good choice, by the way, that you took a job as a C++ software engineer. And this is a lot of fun. Again, I don't know where you start, but I guess it's probably going to be a great experience. All right.
So yeah, let me quickly make that a question. That's like another great thing, keep your questions short. If you like, you have a wall of text, I cannot post this, and I will not post it. Okay. So as a consultant, and yes, so that's a typical problem for embedded, which your clients use C, and how can we convince them to use C++?
So, of course, I'm as a C++ consultant, I never invited by a C company. Therefore, I do not usually have these discussions. Sometimes somebody says that in another team they're still using C for the reason of blah blah blah. Sometimes it's about it's simpler, it's safer, etc. Therefore, I'm not the one that usually has to convince people. The people I teach already use C++. Now, there's a great talk that you definitely know from Dan Sachs, who actually reported from his own career how he tried to convince C developers to use C++. And essentially, the talk is about how he failed. The reason he failed is that many people consider this part of a religion. For them, C is just the thing, they know it, and they're sure that it's the right choice. So very often people just don't want to listen, don't want to get something new, even though we realize it is better, it would be better for them to use C++. So how can we convince them? I think this is one of the toughest things in the world. Seriously, how do you convince somebody who doesn't want to be convinced? Now, of course, there's more open-minded people, no question, but I think without a bigger change in a mindset, this will not work from my perspective, unfortunately, although it really is a shame. I would hope that it is, because so many problems will disappear. And part of this entire discussion about C++ safety concerns is because of this backwards compatibility problem with C. The mindset that some C++ developers still have, using C++ more like a C thing. That's actually, this is now kind of a personal, not personal, a recent experience. Actually, got a book recently released teaching you about important guidelines how to write good software. And you know what? The C++ examples in the book, of course, use for loops instead of algorithms, don't really use const correct. So indeed, it looks more like a C book, C code examples, or C++ is actually a language of choice. So to some extent, it's mindset. The other extent is just that people are so used to using it, to using language in the old way, that's seriously hard to convince them otherwise. It works after all. Yeah. Okay, so I know this is not a convincing answer. This is not an answer what to do, because I feel it's hard. So I'm sorry, I don't have the solution. I just hope that there is that there's a switch in the future somehow, switch in mindset.
What level of C++ are your course participants usually at?
Good question, but difficult to answer, because I basically teach all levels. I regularly have trainings with C++ developers I would consider as a junior, but also sometimes have really advanced classes where we can really go into details, technical details, as well as design details that are quite advanced. What is a reality, unfortunately, is that in every class there is different levels. I have never had a class with people at one level, and so I always have to compromise a little bit. I have to admit that my personal philosophy is that I more address the people with less experience than the people that are more advanced, because I'm deeply convinced that raising the bottom level of a group has so much more effect than pulling the few people that are more advanced up. It really helps to level, or to raise the level from the bottom. And so ultimately, very often it occurs that I'm booked for an advanced training class, and then end up explaining basic things that I believe just help them so much more than the things that would just go over their head. It is a reality indeed. And so perhaps this is an answer that you were looking for. What level are they? Well, not as experienced very often that I would hope for, that the managers that booked the training probably expected, but it's very mixed indeed. Yeah.
Okay, let me go to the next question. What do you think about the key point of software development, the control of complexity in terms of continuous development of C++?
The key point of software development in terms of continuous development, the control of complexity. Okay, so I don't know exactly what you expect, I admit. From my point of view, controlling complexity is absolutely key. Indeed, correct. So what do you think about it? Yes, you are correct. This is key. In my own book, I stripped it down a little bit. Complexity, of course, has several facets, and I focused more on the dependency part of it. How to detangle software such that things are a little more isolated and can be dealt with separately. This was my approach to dealing with the complexity. But there's so much more to it, of course. Next to dependencies, it's of course the readability and the understandability of things. It's how you write some functions, the over-engineering part, the clever part, making things more complex than they need to be, all of these things. So, of course, I feel this is the thing that we have to pay attention to, that we should also teach. This is what I'm focusing on quite a lot in my training classes. Make things simpler, use the tools that are available in the standard library, for instance. Many people just don't know that they're there. So, yeah, I think this is indeed the key. So, good point.
And someone asked about Rust, and it's a very popular question when we talk about things. So, do you have any opinion on like other languages and Rust in specific?
All right. So first of all, I do think Rust is a great addition to the landscape of programming languages. Absolutely. It has a couple of things that no other language has had in that form before. It has a good mix of things. Of course, a couple of reasonable defaults, which is not a big surprise if you have watched what C++ had done wrong in the past couple of decades. So it's a good addition, absolutely. Not convinced, though, that a programming language can be the programming language. Every language has its strength and definitely its weaknesses. So in some areas, as you write, absolutely, definitely. Security, safety concerning areas, this is where Rust shines, and this is definitely where it might have an edge. So in the long run, this is where Rust definitely can take a place. But replacing C++ everywhere, I don't think so. I don't think that the game industry would be happy to to program in a safe mode all the time. It just doesn't help them. No. They have different problems. I also think that if you try to use Rust a little bit, if you try to write something like a GUI or linked list, you realize this just doesn't work. This is not what Rust can do. This is not what Rust was written for. So yes, it definitely has the potential to replace C++ in some areas, but it's not the replacement per se, as so many people make us believe. That's not my opinion.
Okay. There is the next question. We develop lots of code and lots of unit tests along with it. What best practices do you recommend to maintain and test the unit tests?
Test the unit tests. That's a funny question. If the tests are so complicated that you need to test them to be sure that they actually test what they are supposed to test, then probably the tests are too complicated. Of course, this is the usual question. Where does it stop? Now, do I need to test for the tests, and then do I need tests for the tests? No, keep the test simple. The tests are supposed to be your fallback. This is your security backbone for the correctness of your code. Keep them simple so that you can be certain that they do the right thing. And this is key for testing. And then also, my big recommendation is to write tests that you do not have to change every other day. So there's this distinction between white box and black box tests. white box test is a test that tests based on knowing the implementation of the thing that is tested. And that usually tends to be a problem, because if you change the thing on the tests, you have to adapt the test. That is usually something that makes it so much harder to maintain the tests themselves. If, however, you write black box tests, not assuming any implementation, but truly testing the behavior, and tests tend to be so much more stable and also simpler from my experience, which makes it easier to maintain them. You don't have to change them so often. You don't have to write so complex things. And then also the testing frameworks, from my experience, work a little better, a little more natural. Not mentioning any specific thing, but there's good people in the community. So good talks from people in the community have shown that this works fantastically. So no, I don't test my tests, totally admit, but I try to keep them simple and behavioral driven or behavioral focused. This should help. Okay, I hope the answer makes sense.
Okay.
Okay.
So we're getting back to teaching and this question now. What is the hardest feature of C++ to teach and why?
The hardest feature. So if I now count the number of times I've taught move semantics, then this probably is a strong contestant for the first place. Move semantics is pretty much, I teach this pretty much almost every week, perhaps every second week. This is something that is really, really happening a lot. And this is not because people just didn't get the details. There are so many developers today that still have not really used it before or have not really thought about this before. So there is at least 50% of developers in almost every training class. So from that point of view, it definitely is the hardest thing. I do it again and again and again, and hopefully by now reasonably well. If you're really thinking about what is the thing that is hardest to get across, okay, I don't have a particular feature in mind now. Although, okay, I'm thinking about a couple of C++20 things that, however, are a little more complicated by nature, but will get easier. But I'm also thinking about just digging a little deeper into templates. For instance, a one-day training class about advanced templates, and that is something that sometimes is really hard to get across. Why do we actually need type rates? How do they work? How do I actually improve improve compile time when using templates? There's so many little nifty details that people are then very confused about, that it sometimes takes a lot of time to really ponder the details. So that is definitely something I spent a lot of extra time on usually. This is training classes, for instance, where I cannot really go to the end. We stop at some point and say, okay, it was good enough. Unfortunately, we cannot cover this and that topic anymore. Okay.
So we have a geography question. Is C++ more popular in Germany than in other European countries relative to the number of developers?
Okay, honestly, I have no idea about the numbers. I do know, and this may be an indication, that there is a lot of user groups in Germany, whereas in other countries there is not. However, this is probably just because Germany is population-wise the biggest country in Europe, so it's more natural that there's a few more user groups.
I think with the user groups, that has something to do with my conference, because I've been always pushing, and it's not only Germany, there's a lot of other user groups in Europe.
So Germany probably has most of them, but there's indeed many all across Europe by now, which is great. I actually have been to a few of them live, even coincidentally sometimes, and this is truly a thing to enjoy. Being in other user groups in other countries, seeing also the differences, how they do things, it is a great thing to do. But I don't know if C+ is more popular in Germany, generally speaking. I don't know. I'm sorry.
Yeah, I think that's at that point we lack data. It's like one thing which, I have this survey which gives us a lot of data, but getting down to the country level is too many countries in the world to let people choose, and so I cannot answer that question directly. I can see that like Meeting C++ gets like half of their attendance kind of from Germany, and the other half is 40% Europe and 10% people where I know they're coming from somewhere else, or where I really don't know where they're coming from. And
I mean, if I would have to take a guess, there is a lot of industries in Germany that definitely benefit from C++. So it could be that it's more popular based on that. But as you said, we lack the data.
All right. Let me see.
Okay, if you're thinking about it, then it's probably a tough question. So
I just need to copy and paste the question here and then make it show. So may I ask, how long have you taken to write this book, and what are your greatest learnings from becoming an author? Any advice you have for aspiring tech authors?
That's a fair question. So first of all, the book did not appear out of thin air. No, I did not just wake up one morning saying, okay, I'm writing a book about design patterns and design principles. No. So it actually took quite a lot of time to convince me that it is necessary. From my perspective, in a community, we have a lack of knowledge about design patterns in general. And unfortunately, we also have a lot of negative examples to talk about design patterns. Okay, I don't mention any names. I don't mention any other books, but actually there is sources that just made me furious. It was just bad, really bad. And then eventually I discovered that actually design patterns are a good topic. I think it was CPPCon 2019 when I for the first time did a training course, a 2-day training course on design patterns. And this went really well, really well. People were interested in the topic and actually realized, oh my, we actually didn't know so much about design patterns before. And so I realized, okay, actually the topic might be interesting. I may actually be able to teach people something about it. And slowly but steadily, I had the idea, why don't I write a book myself? So why isn't this something that I can do? Because, well, then finally we have a couple of, proper explanations. Okay, this might have been mean, but okay. So I actually then, in the Corona times, suddenly there was a little time. You can imagine that in the first couple of months in the Corona crisis, I didn't really have training classes. It took some time until people realized, oh, we could actually do online trainings. And then I started to prepare things. Yeah, of course, I started to build up my training class even more. And then slowly but steadily, I had ideas how to perhaps write a book too. Then eventually I approached O'Reilly, who had invited me before to give training classes. So this was kind of a good match. I handed in a proposal. This is what I would like to write about. I was personally thinking that I would start probably half a year later. I actually did not expect that things would evolve quickly, but 5 days later, I actually had a yes. When do you start to write? This was super surprising because I didn't expect that. So this was in 2021, in May, to be precise. And then it indeed took me approximately 1.5 years to finish the book. This was not the pure writing time. I actually started to write a little later. So in May, I got the okay, and in June, I started writing. Initially, just 2 chapters, because also I wanted to see what the reaction was, how it worked. But then I believe it was beginning of 2022 that I really wrote almost all of the book in one big quick go. So it took me approximately 2 to 3 months to have 80 to 90% of it. And a couple of training classes got in the way, but then a few months later, I finished the book. But then, of course, the reviewers have to see, look through the manuscript. I had in total 5 initial tech reviewers, good reviewers that took their job seriously. And so I got a lot of feedback, which then, of course, took me time to update the material. It really took time because if you change one thing, you have to change a lot of other things too to keep things consistent. It worked most of the time. Some things, unfortunately, did not. This is one experience I now take from the book myself. But yeah, then once this is done, once the technical authors are happy, you actually get another set of authors who read the book again. This time not from a technical point of view, but from we read through it and give you feedback on whether it reads well and if this is all consistent. When this was done, then I got a copy edit. One person read through the book very, very detailed from a language perspective. Since I'm not a native speaker, actually I got thousands of places to improve. This was a lot of work. And so it altogether took indeed 1.5 years for a 400-page book. The advice for an aspiring tech author, or the greatest learning first. My greatest learning it's actually not too bad. It actually was fun too. But you should have a pretty good idea what you want to write about and how it is structured from the start. Because I actually didn't expect how disciplined they are. They actually set a very strict timetable. I'm not sure what would happen if I would have not made any milestone, but they really have a very, very concrete idea when you are finished with what. And so if you don't have an idea what you want to write about, this may be a problem. At least this was true for Riley, but I believe other publishers are similar. And the advice is, if you do have an idea what you want to write about, and if you feel that there's something missing, and indeed, I feel there's indeed a lot of missing topics in the selection of C++ books, then just get started. I believe this would be a great addition. I'm somebody who obviously collects books. I like to read, and I would be happy to read about something new. Absolutely. So get started, make a plan, make a concrete plan, not just a rough plan in a sense of this is something I could mention. No, make a concrete plan. Also, perhaps think about examples right from the start, and then you are good to go. And then you should be able to do this in a very smooth way. Now, this was now encouragement. I hope this came across.
Okay, next question. Do you think the dramatic increase in the need for very memory and real-time efficient software leads people to use C++ more often?
This may indeed be a reason why C++ currently is apparently on the rise. Of course, there is no concrete numbers again, what we just said. But based on what we currently experience, more and more C++ commits and GitHub, more user groups, more conferences, and now the TOB index who says C++ is surpassing Java. This is a good indication that C++ is currently becoming more popular, which indeed, and I agree, could be because of this kind of performance requirement. C++ was always a performance-driven language, always. And many of the decisions that we don't like actually have to do with performance, or compromises in the committee. But this may be a good reason indeed. Yeah, I agree. Of course, again, there is no data, there is no proof, but I feel you're right.
So, with all the books behind you, what is your favorite?
Okay, of course, everybody expects that I pick my own one. I do not. So, this is a totally different experience. My favorite book. Okay, let me pick it for a second. So, definitely one of my favorites is this one, The Pragmatic Programmer from David Thomas and Andrew Hunt. This is actually the new edition, the 20th anniversary edition. Right next to it is the old one, which I read many, many, many years ago. And this was a book I really loved. I can quote from this book because some of the statements they make are just so good, so right to the point that they really convinced me right off. I also love the writing style. It's not totally entertaining, but I like to read it. I liked and still like. I actually read it twice, of course. And they also have a couple of topics that just today still have totally fascinated me. For instance, something I really loved was their little story about the reason why software degrades, why the quality goes worse. And they actually compared this to a theory from social, what is the right term? So social behavior, so the so-called broken window theory. So the theory is that if you have any neighborhood, then as long as everything's nice, everything stays nice, because people care. People want to live in this nice neighborhood, and they realize that others care about this too, and so they do their job to actually keep things up. Well, but as soon as there's one broken window, things actually might go down, because suddenly people realize, oh, okay, not everybody cares, so why should I? And then slowly, of course, slowly but steadily, decay sets in. And this is something they wrote pretty convincingly. I loved this chapter, absolutely. And still today, this influences me about telling people, do care about your job. Of course, Robert Martin did a great job too, talking about the Boy Scout rule for software development. Leave the code a little cleaner than you found it. But the first time I actually realized this is so important was in this pragmatic program. I really recommend it. It's not that expensive. And make sure that you get the 20th anniversary edition. Has 2 new chapters and feels much newer. They really rewrote a couple of things, because the old one, well, after 15 years, you cannot really give advice on tools anymore. Things are just outdated, some of them.
I've started the day with someone telling me that they recently returned to the project they started their job with. So sometimes the legacy comes back.
I can imagine this is a great experience.
Here's the question.
Your own code from 15 years ago, then, oh my.
So from LinkedIn, a question: what is your take on the NSA recommending not to use C++ for a security point of view?
This is of course, tough question. This is where entire industries can definitely debate for a longer time. I admit that I'm somewhere in between the two opinions. To some extent, I definitely agree with Bjarne, who recently wrote a kind of a rebuttal to the concerns. I'm definitely with Bjarne that C++ has evolved quite a bit. And there's a big if here, if every C++ developer would actually use the things that we can use today, then there wouldn't be an issue anymore. Indeed, there's so many good things today, so many ways that you can express ourselves today that do not have these immediate problems, that the world could be great. However, honestly, this is exactly the problem. Not all people use C++ as it could be used. That's probably the biggest problem. This is also kind of what actually pays my bills. Okay, but since people still use C++ very C-like sometimes, since they just do not use the newest things, stick with the old ways they have done their job for many years, we indeed have these problems still. And so I was asking myself the question, is it the problem of the language, or is it more a problem of the people? And I feel to some extent, it's both. So from my point of view, but this is not just my point of view, this is not what will really happen. From my point of view, we actually should change a couple of things much more radically. So I'm a strong voter for making a big list of things that we want to change, radically change, breaking changes, and just do that in C++ 26. Okay, and perhaps a few more things. But that alone would actually potentially resolve so many issues. So const, I would make const the default. If you don't use anything, it is const. And of course, mutable should be the other thing. I would make every construct explicit by default. I would actually really remove the behavior that copy constructors are always generated, despite the fact that it could be wrong. And so many of these small things, and I would radically get rid of stuff that we know is not good anymore. Old stuff that we have learned is, from today's perspective, just the old style. So this would be my personal opinion. This would be a big step forward. But at the same time, we also have to teach people to actually use the new stuff much more convincingly than we have done in the past. If people today, known people, people that write books, still provide examples that are in good old style C++, then we have missed something in the past. Absolutely. Yeah, I said, I just recently got a book, new book, good style, good advices how to write better code, and examples are just super old. So there is a lot to do. And so once again, I'm somewhere in the middle. I believe Björn is right to some extent. I believe the NSA is right to some extent. Last remark though, and this is the thing that makes me most angry about all of this. I think even the NSA specifically talks about C/C++. I may be wrong, perhaps I misremember, but I think this is exactly the quote. Yeah, so languages like C/C++ or C and C++, people still tend to put these two languages in the same bucket. That is a problem too. If still people consider C++ an extension of C or similar to C, then also we have not communicated our things properly. Seriously. C++ is a fundamentally different language. It has nothing to do with C anymore. It may have a backwards compatibility, but so do all languages. This is the communication layer that we need for interoperability. This is not how we should work today. Okay. So hopefully this explains it.
I think it does. So ChatGPT has become popular. So there is a question on your opinion. Is it helping replacing C++ developers?
Okay, I was just laughing because I pictured myself teaching ChatGPT C++ instead of C++ developers. Now, okay, there's a famous quote, which you probably know too. Björn Sustrup, many years said, software development is a human effort, forget that, or all is lost. And all is lost. So I do think that ChatGPT can actually help to write C++ code. Absolutely. But not with the interesting things, but it can only do the things that we have done so many times before that they just have become boring. The really interesting things, the new things, the things that we're struggling with, definitely cannot be developed by some automated tool. Because after all, let's be honest, this is not an intelligent tool. This is just spitting out stuff that it's seen before. And so it can only be stuff that we have written before, common stuff. So this is why I say it cannot be a help. Absolutely. We can let the mundane stuff do some piece of tool, some tool, and we can actually focus on the things that are truly important, the design things, where we truly need intelligence, a human mind, something that a machine could not do. So from a future point of view, I actually also believe that this is true for the next decades. I do not see a machine replacing developers because, again, the machine can only produce what has been done before. As long as AI is just basically spitting out things from before, as long as it's not really intelligent, I don't see that anything changes here.
Okay, there was a beginner question.
Mm-hmm.
So here, it's about move semantics. I'm not sure if she got that right, but in move semantics, when forwarding reference, we pass an L value, it becomes an L value ampersand, or is it then due to how type deduction works?
That is correct. The problem now is that it's a little hard to explain in words, but the question in the end is actually correct. Yes, a forwarding reference, if you pass an L value, indeed plays the role of an L value reference, and that is due to the deduction rules in the C++ standard. So if you have a t_ref, and say we pass a string, an L value string, then the t is deduced to be a string ref. Just the t. T is becoming string ref. And so essentially it reads string ref space ref. For a short time, during the argument deduction process, there is a string ref space ref. There's no reference to reference though. And so now a process kicks in that is called reference collapsing that, well, just removes one of these references, and the C++ standard dictates that it, in this context, must be the R-value reference. So we strike the R-value reference, and in the end, we have string ref, L-value reference. So it's just a set of rules, nothing more.
Okay, that was an interesting explanation.
Hopefully, interesting.
That was
okay.
Someone asked, any tips when putting together a coding guideline, like for C++ 11 or 14? What would you focus on, and is there like existing examples you would point to?
Okay, so I don't know if you are aware of the C++ core guidelines. That, from my perspective, is an absolutely amazing starting point. Absolutely amazing, because there's already, I don't know, 500, 600 perhaps already guidelines, which are primarily good. There's a few that are not really complete yet. So this is why I say primarily good. But in the things that really matter, so functions and classes and resource management, there's a set of really good guidelines, best practices indeed. This is where you should get started. What I usually recommend in a team is that you take these guidelines and then you work through them. Yeah. So first you say, this is the guidelines that we want to use. You work through them. And then one by one, you might identify a couple of guidelines that are particularly interesting. This is then becoming a couple of favorite guidelines for your team that everybody agrees on and really explicitly says, I agree to. And then there's also a couple of guidelines that just don't make sense for you. You may have a couple of different settings. You may have a couple of different requirements. Perhaps a few are not great. And then you just remove them. You agree that this is not a guideline that you need to adhere to. Slowly over time, you will also find that a couple of things are missing from the core guidelines, things that are particularly important for your project. And this is then what I would formulate separately. So in an additional document, you should formulate which rules you want to have. Sometimes this is, of course, formatting things, whereas I would recommend use Clang format primarily. But there may be other things. I don't have a good example. So I have an example. I cannot just say it's a good example. Many companies, for instance, embedded companies limit you to using signed integers and double values. Nothing else from the fundamental types, primarily to avoid conversions and stuff like that. So if you say this is something we want to use, this is good, then you formulate it separately. Yeah, you say this is an extension of the core guidelines. This is what we also use. And then you, over time, have a perfect set of guidelines that works for you. This is what I would recommend. But indeed, start with the core guidelines. Great place to start.
I agree. There's even books on the core guidelines, etc. Sure. For example, Beautiful C++ from Kate Gregory and Guy Davidson.
Okay.
Which is bringing us basically to the next question, I think. Which is about books. What are your technical programming books which you suggest every software engineer should read? In your book, you recommend John Lake's Large-Scale Software Design and the Gov book. Yeah. Any others?
All right, so I do, of course, have to reference the Gov book quite often because I, of course, explain a lot of design patterns from that book.
That's not
a great reference. I once in a while see on LinkedIn or in the comments of YouTube videos, comments like the Gov book is not good anymore. I disagree. It's a great book still. There's just one problem with the Gov book. The code examples are just totally outdated. Now, the book is from 1994. This is pre-standard C++. And definitely the code examples are terrible. Some of the examples are even misleading. They actually show the pattern, but there's so much other stuff in there too that people misunderstand the patterns. So no, the code examples are bad. The book is great. So I would actually not recommend to read it from front to back because it's, okay, let's be honest, so boring. John's books are brilliant. I really like them, but okay, you see this book here? It's almost the biggest book in my bookshelf. John Lakers tends to write big books. His newest book is, so this is 1,000 pages, pretty much exactly 1,000 page. And this is not something that you just read lightly. It takes a long time. That's a huge disadvantage. So it's good, but he tends to write too much, unfortunately. So books that I would recommend, technical books that I would recommend. I am a great fan or a friend of clean code, not because every single item is good, but this is one of these motivating books, these books that try to convince you that actually putting effort into keeping your code good, clean, is well invested time. And I totally agree. This is a motivation book. This is what I would hope every C++ developer reads. I think I didn't reference this in my book, unfortunately. No. Then, okay, I just showed it. This is what I would recommend. This book contains approximately 50 items. How do they call this? Tips, whatever. So 50 items they also consider as guidelines. Interestingly, 20 years ago, they actually recommended the things that we still recommend today. Separate concerns, don't repeat yourself. It's exactly those guidelines that we, as an industry today, consider as super important. So this is probably the go-to place to find all of these guidelines in a very concise, very well explained way. Okay. And I'm thinking it's probably the two books that I would definitely pick from all of them. So, funny enough, this is not C++ books, but there's not the one C++ book currently that I would recommend. Either they are very centric to a particular standard, which is good. We need that. Or they are very general, more like introduction books, which is not something that I would generally recommend. Okay, so this is my two recommendations.
Yes, I saw an interesting question from LinkedIn. Klaus, you are talking a lot about object orientation in your talks. Can you share your thoughts on data-oriented design?
Absolutely. Okay, it looks like I'm actually talking a lot about OOP. I admit the reason is that, of course, I often start with an Gov pattern, a Gang of 4 pattern. The reason is that this is, from my perspective, the place where I can actually where I can meet people. Now, this is what people know. And so if I start with this, I have people on my side already, in the sense of they know what I'm talking about. But then hopefully I'm actually moving away from this a little bit. For instance, in one of my latest talks at CPPCon 2022, I talked about the visitor design pattern, and indeed started with a good old visitor from the Gov book, but then actually showed how this is done today in modern C++. And the solution is, well, not object-oriented at all. It's more like a procedural, functional approach. That is the right approach, the right paradigm for a visitor design pattern. So I'm not an OOP practitioner. I'm more like well, what's the right word? So I'm pragmatic about how to approach a problem. I try to find the best solution for every problem. If the solution is object-oriented, great. Then this works best. If it's functional procedural, great. Then this works best. What I do try, however, definitely is to show people that value semantics is the way to go, which also addresses some of these security issues that we've mentioned before. Encapsulating things in values, dealing with values, not dealing with pointers, dealing with way less references, not using so much inheritance, etc., etc. Type ratio, for instance, kind of inheritance free on the outside, I would rate this as an object-oriented programming solution from the sense of it has the same advantages as the object-oriented programming paradigm. But as a value semantic solution, it just has so many advantages. Okay, this was not really the answer to the question so far. So, data-oriented design. I think this is another good approach. Absolutely, I like it. And I actually have the one book from Richard Fabian, the data-oriented design book, and I think that still is just one. I've just one beef with pretty much all of the talks and books. They pretty much make it sound like object-oriented programming is the wrong approach. I don't agree with that statement. They make it appear so. Probably they don't mean it this way, but they make it appear that way. Object-oriented programming is a great approach if it's the right one. And the same is true for data-oriented design. I think this is a great approach for those places where it's actually the right approach. So I would not write a GUI with data-oriented design. But I would definitely think about this when performance is a little more critical. In computer games, it really seems to fit well. So yeah, I believe this is a great addition to the multi-paradigm field of C++. Yeah, I didn't write about this in my book. Perhaps this is something that I should rethink in the next book. Because again, I want to show that there's so many different kinds of solutions, and from that perspective, this may be a good pointer for me. Okay, thanks for the question.
You mentioned the next book.
I mentioned that I'm actually thinking about another book. I mentioned that I have a lot of other patterns and ideas that I did not put into the first one. And if I write a new book, indeed, it might actually be a reasonable idea to include a couple more different kinds of solutions. Daniela Engert complained that I did not use enough templates, so she was a little disappointed that there was not enough static polymorphism in there. This might be something that I can change. Yeah, now I have a different idea what actually would fit pretty well. That's what I want to show, the multitude of solutions.
Yeah, I think there's a couple of things you could connect with when reading the book and as a second book.
Yeah.
So we're getting a bit back to the language questions. For someone who stopped working with C++ for almost 4 years using C++ 14, any advices that will help me to catch the gap as nowadays the C++, it's C++ 20?
Yeah. All right. If you do have indeed the opportunity to work with C++ 20, this is great because so many other people unfortunately cannot. I would not say that you should have to immediately learn about all the new things and use them right away. I think this is not the right approach. The right approach is to know about them, learn about them bit by bit, and then apply them when they're actually appropriate. The one thing, however, that I feel really, really makes a difference, and I know that Daniela will hate me, but concepts. This is the one thing from C++ 20 that I can use in all compilers today, and it really makes such a big difference in terms of code quality, how we think about templates and templated code. That's the one thing that you definitely should look up. Else, of course, there's so much new stuff. One thing that definitely helps is to just keep up to date by watching a couple of CPCon videos. Also, not all of them at once. This is just too much information. But yeah, go in there again, bit by bit. Pick one thing at a time and try to realize why this has been actually added to the standard, how it helps. And there's things that are more important than others, of course. Yeah. By the way, I actually feel this is a good choice to going back. It is more fun today. So many years ago, I was actually thinking about problems. Today, they are not a problem anymore. So many things have turned to the better. Absolutely. And so probably you'll just find that it's easier. Hopefully. Of course, there's more stuff, more complexity, but because of this new stuff, you can forget about old stuff. And like variant, if you use a variant, you can potentially forget about union altogether. So new stuff replaces old stuff in many cases. Okay, hopefully this helps.
Yeah, I think I'm still a bit torn with C++ 20.
I am too. Absolutely.
the problem is actually not the standard. The implementations are not always up to speed. And so
that is why we for 20 up to date.
Yet where you just magically can write code with concepts and modules.
We're not there yet.
Daniela demonstrated that in her keynote how that would look, and that there are certain combinations where this works out. But for some of us, this world is now getting closer, and I think that's great.
Yeah. By the way, is it indeed a problem in our training classes? Many people expect that I talk about C++20, and then afterwards they can use all of these great new things. And then, unfortunately, the training that I have to reveal to them that, oh, by the way, your compiler doesn't support that. Oh, no, your compiler cannot do this too. Unfortunately, this is also not yet possible. This is actually a disappointment for many people. So we are not there yet.
The next question is probably also something which you hear a lot in your trainings. Lots of C++ code is written with procedural programming mindset, maybe due to influence from C. And it's just C with classes code. How do you refactor such code?
It's, of course, a big question. This is now something that we could do a training class on. The first thing to try to do, this is also something Kate Gregory says, if it's truly a very C-like code, then probably, I said probably, you'll find a lot of manual resource releases all of the code. Yeah, manual deletes, closes, etc. That definitely is the first thing that must go. From today's perspective, in C++, this is a programming error, a manual delete, a manual close. If this is already encapsulated properly, and you already are in a reasonable shape to clean things up more easily. Oh. But then it's a very general question. I cannot generally answer how to refactor this. This is something that I usually do in a consulting session. Yeah, we take a look at the code, we plan ahead, we actually decide on what is a reasonable course of action. It's a little hard to just say in general form. Yeah. By the way, very often I see the opposite too. People that actually use C++ not as a C with classes code, but as a Java thing. So deep inheritance hierarchies, pretty much everything is solved by inheritance hierarchies. This is a reality out there too. And also a problem, because deep inheritance hierarchies are things that people don't understand anymore. My experience.
I mean, one advantage of having C-like code might be that you already have a lot of free functions. But
okay, from my perspective, this may be a different thing.
I have, I had my fair share as a freelancer of seeing code bases, and it can be very difficult and very different.
Yep.
It's not like there's not the standard code base, which everything. So Herb Sutter proposed also his own language. It's like it was a pattern last year that a lot of people came up with a successor or improvement language on C++. So what's your take on CPP2 and Herb's presentation?
Okay. I actually really liked the point in his talk where he actually blanked his slide and talked freely. Because indeed, he addresses in this talk exactly the problem that we currently are facing. C++ is moving forward, yes, but unfortunately slowly, too slowly. And he's right, too slowly because people are just not interested in learning new stuff. And we still have the problems to some extent that we had 20 years ago. So I think in the presence of all of these other languages that actually are very reasonable, very good additions, C++ must evolve a little more quickly and a little more radically. We cannot uphold this backwards compatibility forever. We must actually break things a little more radically. And so I really admire him for actually making a suggestion that is pretty radical, but at the same time makes sense. I do not see this as this is how it's going to be. But it definitely is something that stirs up the discussion about this topic, and also hopefully changes people's minds a little bit, because I believe he is absolutely correct. If we continue as we currently continue, then we hit a wall at some point, and indeed, then C++ might actually decline. It is a great language. It's actually probably still the most powerful language that you have, but we need to overcome the problems that we have one way or another. And this requires some radical thinking. So I like what he's done in the sense of radical. I cannot really say if this is the things, if this is the thing how things work out in the future. We'll see, but we need to do more, a little more explicit, break old things in order to move forward.
Yeah, I think what my initial reaction to his keynote was that, well, let's see how this moves forward. And I'm actually kind of happy to see that Herb actually has moved this forward, that this is now an active project and that there is updates on it. And because there's, Herb likes to give very visionary keynotes at the end of CPPCon, and not every of those keynotes has, been in retrospect. It's now leading all to this, and maybe it's all coming together. But sometimes you can also have it's a science project, and this is really going somewhere. On the other hand, we did an ARMA with Sean Parent, and there Sean gave it a bit of an insight that there's actually like a big community of people working on those languages, and they're talking to each other. So the CPP2 folks meet up with the VAL folks and the Carbon folks, and there was another language,
which is great.
Probably, and there. It was like, and I think from that, and Circle I should mention on this, even if like Circle exists for a long time, and it's not like I think he doesn't want to be mentioned as a successor language. So
which I feel is great. We should learn from each other.
I
think it's a
competition. For C++, and we'll see where that goes. And yeah, so I think we're through with that. We're like, do you want to ask a few more questions, or?
So I don't mind a few more questions, but you are the person in charge. You say when we are done.
Yes, let's see if there is one last question.
All right.
So here's a question on classical design patterns. When is the solution following a classical design pattern, and when is it just code with similar intent?
All right. So I don't see the question yet, but I think I got it nonetheless. Okay. One of the things that I consider a misconception about these classic design patterns is that people expect that they look exactly like in a Gang of Four book. So this actually was also one of the questions that I got at the end of my keynote talk. Should we use these design patterns if they look like this? Or it was posed a little differently. But people expect indeed that everything's done in inheritance, and then it's a design pattern. Design patterns are definitely more than that. They are generally dependency structures. How do you want your entities to depend on each other? Depending on how you want them to depend, you are actually using a design pattern. And so when a solution is following a classical design pattern, it has a certain dependency structure. And then it's totally relevant how you implement this. Like I said, the visitor, the classical design pattern can very, very well be implemented with a variant. Actually, you decouple even more and have the same, in the end, dependency structure. So from my point of view, you are using a classic design pattern once you indeed follow the intent of that pattern. If you want to be able to inject implementation details from the outside, you are using strategy, whether you're using a base class, whether you're using a function pointer, a std function, or a template parameter. Doesn't matter. You're using this particular design pattern. Same with pretty much all the others. There's a few that are very specific. I could not name any other solution for the prototype pattern than inheritance. It is for inheritance. But yeah, similar intent, probably meaning more same intent. Whatever you do, you use this pattern. Okay. Okay. Jens, are you muted?
Yeah, I'm muted for the first time. Great. So There are killer features in C++ 20 and 23 that would encourage their adoption. For example, features that will improve security, given that C++ has been described as unsafe recently. So,
killer features for security. Okay. I've not thought about it this way. There is killer features, definitely. This is why we definitely consider C++ 20 as a big step. Yeah, and 23 as a very, very reasonable addition to that. I don't know if there's any killer feature for security. I think since features take so many years to actually develop, to evolve, to actually put into a form that you can standardize them, probably when the C++ 20 features were thought of, nobody was thinking about unsafe at the time. This is just things that we have been missing for decades. In the first implementation of the STL, Alexander Stepanov already used concepts, the idea. Today in C++ 20, we finally got them. 3 decades later, essentially. I think there's nothing focused on safety or security. Security, because from a timescale point of view, nobody was focusing on that yet. Probably a couple of things will change. I think, once again, the most critical things about unsafe that we hear about today is still that you can use the old stuff, that you that people also don't want to update because this is what they've done all their life. That is the major problem. This is something that you probably cannot even fix with features, but only with breaking old stuff. Breaking the sense of really getting rid of that. It's super difficult topic.
I think the concepts is a good improvement to finally nail down interfaces and make things more transparent to what actually your implementation is supposed to do, and to be, make it easier to catch certain things at compile time. I also 23 is like one of the features everyone talks about is deducing this. And I find it interesting that this kind of is reducing the code complexity and the amount of code you have, and that is also an improvement in security potentially.
Potentially, absolutely. From that perspective, everything adds a little bit. It's not the big killer feature that was.
So I think the recent paper from Bjarne has made it clear that the focus of the committee has recently not been so much on having a killer feature for security, and we are all, of course, in the C++ community, willing to listen to someone having such a killer feature as an idea. There is now one last question, I think. Let me see if there's more questions which we could bring in here as their most voted question. Well, there's one more question. Let me copy that, and then there's a good question from LinkedIn to end this.
All right.
What are your greatest learnings switching from software industry to training, consult, author, speaker career? Any advice for similar-minded tech people in software industry?
The greatest learnings, the greatest new things. Okay, so I didn't switch quickly. I should say that for a long time, I have always done training. In the first company I have been, when I started, everybody, I think, quickly realized, oh, this guy knows C++. And so after half a year, I actually took over the internal C++ trainings. So I went to all the sites and helped people to better understand what they should do, how to write their software. When I switched to my second company, very quickly, I actually was doing C++ trainings internally. And again, I went to all the sites and did training classes. I think because of that, and probably also because at the university I have done teaching, I realized that teaching is actually something I like, something I enjoy. And also, my opinion may not be true, but I believe I can actually help more in spreading the knowledge than doing stuff on my own. And so eventually I asked for reducing my work time to part-time. So then I did part-time work in a company, part-time training classes, which actually worked great. I was super happy with this, but it did not work out quite as I intended it. The company didn't like the fact that I was there only part-time. So eventually I had to choose, and I chose to do training classes my whole time, which actually happened kind of at the beginning of Corona, which was a little unfortunate choice at that time, but it turned out quite okay in the end. Yeah, so today I really can make a living based on these training classes. So it was a slow transition from few training classes, once every 4 weeks perhaps, to now one pretty much every week. So it was a fast transition. So I think there was not so much of a big learning. It's a surprise, like, oh, this is now something I didn't expect. There is some advice for similar-minded tech people. Do not just jump off to start to say, yeah, now I'm doing training classes. You should have kind of an idea already how many customers you will have. That is something I initially considered as a risk. And I was lucky to already have a lot of people that knew me based on the Munich C++ user group. So not surprisingly, a lot of my first training classes were in Munich, and where people knew me already. That is something that I consider to be pretty important, because else you might be disappointed. You do not want to ask people, do you want a training class all the time? You actually, of course, eventually want that people ask for trainings with you. And this definitely takes some time. Therefore, know a couple of customers up front, then this might work out just well. Yeah, build a reputation. For instance, by the way, by giving talks. If you give C++ talks that people like, that people make people realize that you know something that you can also teach well, then it definitely helps to convince people to come to you.
Yeah, I used to give classes, and was trying to see if being a trainer is a good sidekick for organizing a conference. And one of the problems I had is like that some of the trainer market where you can get into is very similar to the freelancer market, where you sign off to some company which has some customer wanting to have a training, and you give away the rights to that company to those middle folks, and those middle folks take away the interesting of the,
exactly
of the training to you partly. Yeah. And on the other hand, in that setup, a lot of information can get lost, and that happened to me in one training where they were very particularly asking about the boost threat training. So they got to boost threat training, but they kind of forgot to told me that there were beginners in the audience. So the more advanced people in the audience liked it, and I kind of felt they got the training which they wanted. But that's the other thing which I really have to tell you if you want to be a trainer. Get a feeling for it, what class size and what teaching and doing trainings in the real setting, if that's something for you or not.
Yep.
And I found it interesting when I got a hold of Scott Myers in 2014 at my conference. I was like, I know the one question I want to ask Scott Myers, and I was like, Scott, so when I do a training class and I'm done with the day, I'm excited, but I'm also exhausted. I'm not like, I just, want to have like, dinner and then I'm done. And when the class is ready or when the class is done, I'm like done for the week. Or like I need really like a day or two to recover from that. And I was like, Scott, you're giving so many courses. You must know the secret sauce to, not do that. I know how is it for you? And he was like, yeah, that's true. It's and one part of it, he was like, for him or from his perspective, it was also like that people can ask you questions anytime of their choosing.
Yep.
And you kind of have to constantly try to answer their questions in a satisfying way.
Yep. That definitely is part of the challenge. Absolutely. I agree. If this is something that you like, so again, about the question, if this is something you enjoy, then this may be the right thing for you. A little bit of teaching experience may help, as Jens said, knowing how this works. Absolutely. So before you choose this career path.
And the final question has also something to do with trainings. They asked where to find Klauss trainings class.
So usually, indeed, as I said, most customers come to me. So I usually am contacted by email, but you can definitely find me on LinkedIn too, which is based on my last name, a very, very simple way. Just contact me, and then suddenly we are in a position to exchange information. So what I usually need to know is, what do you have in mind? How big is the group that I'm supposed to teach? What exactly you're interested in? Do you have a specific idea, or is it just about give us an update of the of C++, something like that? And also, pretty important for my preparation is a little bit of an idea of the level of developers. As I said, it never fits well. There's always a homogeneous group, but I can prepare it definitely better if I know upfront whether this is advanced developers or less experienced developers. So LinkedIn, Klaus Iglberger, or if you take my last name, put a dot in between, so klaus.iglberger at gmx.de. gmx.de. This will work pretty well. All right.
Sure. And your classes, your material, do you have any preparations or plans for having video courses available online?
I do have a lot of YouTube videos by now. So if you go to YouTube, search for my name, probably in combination with Meeting C++ or CPPCon, then you do find a lot of videos. This is, to some extent, appetizers for the training classes. If you like the talks, then you will also like the teaching style in the courses. If you, so I do not have other video courses. I do have video courses, but they're commercial. They're not freely available. So the Heise group, for instance, offers a training course, so videos with me. Okay, so the YouTube videos are definitely the best way to get an impression. Absolutely.
But you're not having a course on the popular online platforms like Udemy or other things like that.
No.
Okay. And of course, the book. If you want to get to know more about what Klaus thinks about C++ software design.
If you enjoy the book, indeed, then a training class might work. You will find that the book is not a dry read, but I usually like to write a little more entertaining. If I like to write the book, then it's a good thing. And so there's a couple of jokes in there. If you like these, then the training class should be just great. Yeah.
And with that, we are now at the 90-minute mark, which I think is also kind of,
Absolutely.
a little bit where we want to go with Klaus tonight. Thank you for coming, Klaus. It was an honor to have you. And I'm looking forward to what you're coming up with and talks and other things in the future, what we see from you.
Then once again, thank you very much for the invitation. I really enjoyed this. Thank you.